Hey, welcome back. This will be episode number 6 of my Learning Industrial Robots programming. So basically in the last video, I forgot to really show how you tell these move instructions to go to these new points. I sort of did it by hand, but essentially what you want to do is sync this pyramid tool data over to your virtual controller in Rapid Land. So just do a synchronize to Rapid and make sure it's checked. And I usually put it in user here. That's just a good place to put it where you won't have to really sync user too much, and I prefer it that way because then you can't screw up the user space. So um, what that looks like here once you've synced it is there's this user module down here. I want to say it's a system module or something, and they show you some generic stuff in here. It's kind of funny, just numbers, variables, and stuff, and a clock and stuff. But here's what we added. Um, and let's fix our formatting. Pyramid tool data here, and then this is robot holds tool, XYZ, rotation, all that good stuff, right? So we head over to our path that we created, and here's where it's saying what those work objects are. So here we'll do pyramid tool data, pyramid tool data, pyramid tool data. So it's saying, hey, create these or run these points, go through them all, but I want you to do it with the tool, not with the flange, which is what we were doing before. So we can apply that, hopefully go run it. Let's see, expected type of work object data and found tool data. Ah, my bad. Um, let's see, I messed that up. WOBJ0 is what we wanted there. And here is where we wanted pyramid tool data. So their syntax is super weird with these slashes, and these are optional arguments with a slash, and these are required arguments. So I guess if you don't provide a work object, it probably just assumes world anyway. But that should do it. Let's see if it's happy now. No errors. Home. Let's run it, and let's see. Boom. There, our tool's at the path. Perfect. That's exactly what we wanted. And he's doing those joint moves through there. So everything looks good there, but I guess we still have a problem is uh, why do we want to do this with our tool? Before it was why do we want to fling the flange around in the air. Now it's why do we want to move the tool through the air here. So let's at least get closer to pretending we're doing something real. So um, let's say, for instance, we could just use this controller as a an object that we're going to mess with. Wow, that's an odd coordinate system it carries with it. Probably I did that. Let's go ahead and rotate this guy. I think you can hold Alt. No, I don't want to do that. Oh, there we go. Okay. So here we go. I must have been in a weird coordinate system there. So let's move him over where we can get to him and reach him and do some things to it. So what we're going to do is create some points on here, but you got to keep in mind that when you put these two objects down next to each other, in the real world, this is in simulation, so I can measure the exact point from here to here, and everything's good to go. But when you put it in the real world, they're not going to be right. They're going to be off a little bit in all 6 degrees of freedom. So what we want to do is train this point or teach this point and say, hey, robot, this is an object you want to deal with, and you want to do some work on that object. And so what you want to do basically is create a work object. This would be like in FANUC would be a user frame. I don't recall what KUKA calls it, but everybody's got this same concept. It's something you want to do some work on. So we'll create a work object here. Here, let me make these bigger. Robot holds work object. It doesn't. That's a little more advanced functionality. In this case, the robot's sitting on the ground. So if you were in a multi-robot system here, you could have one robot hold a work object, and as it's moving, all that good stuff. It's crazy. So you say, hey, it's moved by an extra axis. Like if you have a conveyor or something coming by, it can be moved. Programmed relates to that as well. But basically programmed is saying we're programming this in, it's not coming from an external unit. So the position of the user frame here, we have user and object. So user is sort of the general area, or what I would call, kind of consider this the fixturing. And an object would be if you have multiple objects on a table and you want to go work on each one. It's really just sort of a nesting, from what I can tell, of these two user frames. So it's like an object frame is the ability to create a user frame within a user frame, if that makes sense. So you'll know more about user frames in a second if you don't already. So it's asking, where do we want this? So what we want to do is pick a point, and the points, when you know, hopefully your fixture has a nice sharp edge on it or something like that that you can go and touch off with this tool, or you can measure some other way that's useful. But on this cabinet, you know, this junk's in the way down here, these linear rails for the crane hoist points or the forklift points. So let's just use this, and it should populate this, but it didn't because this is weird, and you have to click. It's so weird. Boom. You highlight the thing, you click the thing, and then it's good. So I'll accept that, and then the rotation is, you know, if this was sitting on a hill or something like that, or if it was angled some amount, 45 degrees or something, that's fine. In simulation, rotation will often just be 0 because you're dealing with perfectly flat, level planes that you don't need to accommodate or consider. But in the real world, when you redefine this work object in a real world manner, you're going to have a roll, pitch, and a yaw for this once you've taught the point. And it may be, you know, hopefully if your aim is to get it flat, then it's flat within, you know, some small amount, but you don't really want to just assume it's flat because you can measure it. So, you know, by the time you assume it's flat and you're over here, you may be a millimeter or two off the part, and that's not good. So this work objects helps us teach these points and kind of you know, handle these variations in the world and how the parts actually land. So we'll leave those at 0 for now, and this is a way to get those values as well by doing points, which is sort of similar how you teach them on the robot typically. And it's putting in the module, yeah, everything else is good. So now we have a work object, so kind of like we did the tool and had the ability to put that anywhere we want, we can now put targets and put them with respect to the work object. So what we can do is, actually, I want to target, and I really want to, for some reason I kind of always thought this would be funny to do, is to make a robot push its own e-stop. So I'm going to pretend we're doing that, and let me see if I can get a point snapped on there, or at least a close enough point. So reference here, we'll say work object, and we'll pick our work object, which is, I should call it controller 1, but it's robot, or it's a work object 1, and we'll call this target e-stop, something good like that. And then I'll highlight this, and then I just need a point to snap to. So that's target mode. I want to be in not that mode. I want, come on, where's my points? Where's my little snapper points? There we go. They're coming back now. I'll just put this guy here, and I'll move him over as soon as he's made, because it doesn't want to snap to the middle of that. But so we've got 1 point, target e-stop. He already appended my 10 on there. Everything else looks good. So I'll create that point, close this, and go to it. Why has it created that point there? That makes no sense. Let's try again. Create a target, work object referenced, point. I see the point where I clicked before. Click, -150 and Z. Okay, so that's with respect to this. Where are we? So everything else looks good. Target e-stop. Alright, he's there now. What have I done? I don't know how that happened. Point is in the right spot though. That's where we want it. I'll go ahead and just center it up a little bit, get it close. So this, if we want to view the robot at that target, we will right click, view robot at target. Oh, it was already on. View robot at target, saying he's out of reach. So this coordinate system needs to match that, and clearly our Z is pointed straight up, so the robot can't reach it. So we can either move our box or we can move our rotate our target. So let's try this first. Let's see if we can just free rotate it and get the okay, that's getting close. Yeah, that's what we want right there. However, not very straight on there, so should have made this tool smaller. Okay, so we've got the robot right on that point, and everything should be good. So let's go ahead and synchronize that. Oh, actually, let's go ahead and add this to a new path. So let's say push E stop. It doesn't like that. Push E stop. There we go. And I can right click here, synchronize to rapid, or we could do it the traditional way, I guess. So this is the only one that changed. We'll put it in module 1. That's fine. We now have our work object is syncing at the same time. So you can see now we have our new proc here, our move linear to the E-stop, and a velocity of 30, which is the default we had set when we were playing around in episode 2, I think. Pyramid tool is the tool we want to put on there, and work object is related to work object 1. So as this work object moves around in physical space, this point, which is referenced to that work object, you can see here this -150, it's not underground. So it's actually referenced directly to this coordinate system here. So and its -z is down, and that's where this point is. So as this guy moves, this point will move with it. That's important because as soon as we add a second controller in here, we can use that same, or we can make a new work object and it'll know where that point is with respect to the corner of this. Hopefully that makes sense. So we need to go ahead and get the robot to go down there. Go ahead and just play around, see what we can get going here. In rapid, open path 10, so I'll first move to target 10. I'll move to the E-stop, and then I'll move back. Let's see if that works. No errors. Applied. Oh, okay, so we just ran the old program because I'm really running this main endpoint here. So let's ignore path 10. We'll comment that out. Push E-stop, semicolon. Let's try this again. Mistakes are good sometimes because then it's a learning experience. Oh, he's going slow. 30 millimeters a second. So watch what this robot's doing. I'd put it as a linear move, and so he's trying to make sure that this coordinate is going on a straight path through there. Like, let's look at the path instead. I'll go turn. Oh, I need to sync it back to the station so I can interact with it here. Come on. Okay, so there's this path now. Let's hide the other one. View, visible. So you can see this path, but he's actually doing a linear move. And see, I think that should be fine, actually. It's a little tight on these robot joints and things, but we could do a joint move and have him get to the same spot, but he would just not follow this path perfectly. He'd get there a lot faster, though, if we wanted to go faster. So, you know, in this case, we don't need to constrain him. We're just going here. So, anyway, that's about it for work objects. I'll demonstrate that again in the next video. Let's see what the next one is. It's motion points and types. Yeah, we'll just do more of this, and we'll get some different things done and actually pretend we're hitting the E-stop and all that good stuff. So check out the next video, and we'll move on from there.